So let's now really focus in on the development of that kind of technology, so the model building, right? So there are two things that I want to ask you. One, the first is it sounds like you would agree with this sort of premise that AI is really eating software. Like, what is it? Software was eating the enterprise, and now we're saying a lot of folks are like, AI is eating software. Most things are going to be AI and not really hard coded software. Agree or disagree? Let's start with that, and then I'll go to the next
I'll
one.
say I partially agree with it. Look, what I think that there's things that AI can do that naturally traditional software can't do, right? Like we couldn't teach traditional software how to recognize cats or recognize a tumor,
Right.
right?
We
And AI,
tried, but the rules got too complex too fast, and it just didn't
right?
work.
It didn't work even with spam, right? We don't think of the spam
Right.
detection as AI, but that is right. It's Bayesian
Right.
filter,
Bayesian
and
filters, right.
when we that's sort of early artificial intelligence. When we try to do rule based systems, it just was like a towering inferno,
Mm-hmm.
it would just come crashing down. It didn't really work very well because humans are very ingenious at getting around blockades, right?
Right.
So. My thinking is I don't like the idea that AI eats all software, right? Because I think there are certain things that like Elon Musk says, look, I discourage the use of machine learning in a lot of applications because sometimes it's too complicated or you don't need it, right? It's like if I'm
Right
writing a
tool for the
login,
job.
right? I'm writing a login system. I don't need an AI to write the login
Yeah.
system.
Yeah.
You can go back and look at 50 different examples out there of how
Yeah.
to do it,
Exactly.
right? So just do those things. But there is a whole series of new problems that we just haven't been able to solve with traditional hand coding. We've reached the limits of that. And those are the types of problems we're going to be able to solve now. And that's what's really exciting. You look at something again like the AlphaFold 2, that is a problem you literally cannot solve through brute force. You can't solve through hand coded logic, but you can solve it through AI. There's a number of problems that fit into that domain. And it's
Mm-hmm.
going to be very exciting to see those start to take shape over the next 20, 30 years.
So software development life cycle is very well known, right? For the last 20, maybe more years, maybe more decades, but we've been building these systems and processes and tooling and language and kind of a culture around software development. And so I think most people in most sort of Western, let's say modern technical environments would go, yeah, we all kind of know what you mean when you say software development life cycle. We know what you mean when you say continuous integration, continuous development, agile development. All of these things are kind of known. The processes and the tooling and the tool chains exist now after 20 years. And you were a bit, you played a part of that being over at Red Hat. There's a current focus right now, which I want to get your opinion on. I'm not personally a fan of this kind of like focus on MLOps is the same thing. Because to me, MLOps is really just DevOps, except pulled forward to the model world. So what I mean by that is it's moving from dev to production, getting the thing out of training and into production, which is a tiny subset of really the model development lifecycle, which is what is my business problem? Should I use machine learning to solve it? Okay, well, what algorithms and can we train the models and do we have the data? Yes, we've trained it. Now we can put it into production. Now is it still working? And is it doing the right thing or do we need to retrain it or do we need to decommission it? To me, that's the full model development lifecycle. And I think that the software development lifecycle and the model development lifecycle are two systems that sit side by side. They're parallel inside your product development lifecycle, if that makes sense. Does that framework make sense to you?
It makes sense. Look, first of all, the term MLOps though is evolving, right?
Yeah.
And like any term when it comes to like we tend to think of terms as fixed, but that's only because the term is fully baked by the time it comes to us. Whereas we forget that there's a period of time where people are trying to come up with the correct term. There are terms that don't work, and then
Right.
and then they try to say, well, is this? It only applies to this. Or I am of the opinion that machine learning operations, and that's the way I think of it, is everything from sort of the data ingestion all the way to putting the model in production, monitoring, managing it, auditing it, right? In every stage in between. And there's also, I think you were hinting at it in the earlier phase, and I'm sure we'll get to this anyway, but there are very different steps between the classical development life cycle
Mm-hmm.
and the machine learning life cycle. And the problem is a lot of the early tools tried to just port over the DevOps life cycle,
Right.
and there are fundamentally different steps that we're missing when we're talking about machine learning operations. I think it actually is 100% goes through the entire life cycle, and we forget that this term is still being defined, right? A lot of times we inherit a term in life and we think that it's it always meant that thing, it's fully baked. But the fact
Mm-hmm.
is, in the early days, there's a lot of people trying to come up with the correct term
Right.
and then define what that term means, and that's
Mm-hmm.
part of the evolution of it. That's where we're at now. So
Okay.
for me, machine learning operations is from all the way from data ingestion all the way to putting a model in production, monitoring, managing it, and auditing it and kind of rolling back through. There's a lot of stages in there that don't match with the traditional DevOps and traditional, hand-coded logic lifecycle. There's no analogy to the training stage, for instance, right?
Right.
You generally don't have things like synthetic data in there, right?
Right.
And there's also a different focus. Like I think one of the failures of many early projects was just trying to port over that DevOps focus. So you look at something like, QFlow, for instance, and it very much is a thing that has a focus on kind of a DevOps mentality. It's almost like hand-coded logic and data is secondary.
For somebody who doesn't know what QFlow is, just what's the
Yep.
30-second version of that?
The QFlow is designed to be kind of an interoperable Gloom framework that for machine learning that unites a lot of different components on Kubernetes-based platforms. But I think it's mostly developed into basically a Python pipelining system, right? And I think it had a broader kind of vision, but I don't think it quite hit that mark. Maybe it will in the future. Open source projects can evolve, and I don't like to say anything bad about open source projects. I think it's amazing when people come together, but
Right.
but sometimes it doesn't work perfectly the way you initially designed. And I think what they're trying to build, and what I want to build with the Artificial Intelligence Infrastructure Alliance is an abstract data factory, a Kubernetes of machine learning at some point. I think it takes 10 years to get there.
Yeah.
The reason is because if you take you just try to take the template that you already have and port it over, it doesn't work.
Right.
And it doesn't work because if I have a hand-coded logic, for instance, like we talked about earlier, I write the login and I write all the rules for that login, and the data is secondary. I only touch the data for the username and password,
Right.
and it's secondary. And so naturally, the original coder's idea is to mirror that process. The problem is, in artificial intelligence, the data is primary, and
Right.
it learns from that data. And 80% of your time is spent, corralling that data, pulling it out of 12 different sources, threading the RBAC control, transforming it into
Normalizing
a different format,
that data.
normalizing it, cleaning it, getting it
Yeah.
out, and then even Andrea talks about this a lot, right? Where you sometimes you throw 5 different algorithms at it, and you get a 0.2% better difference, and then you go back and you realize, well, the bounding boxes, we had 40 guys doing the bounding boxes, and all of a sudden they all interpreted our heuristic a little bit differently about where to draw the bounding box. So let's go back and clarify that, and all of a sudden have 30% of them redone, and all of a sudden now we've got 20% better performance, right? So there are all these stages that really just don't exist, and what you have to do is you have to go through these kind of pioneering systems who run into these problems and just run right into the wall of these unexpected problems, right? Like the team at Uber, they built Michelangelo, and they go, well, this is going to be the general purpose system that does everything. And what they found is it did the 2 things they designed it for and nothing else. So they basically broke it up, into 50 other projects, right? And half the guys left and started Tecton, and a feature store, right? It's like, so these kinds of things, you don't know you have the problem until you run into it. It's an unknown,
Right.
and then the tools start to develop. So you really can take inspiration and ideas from a lot of the old models.
Yeah.
There's a whole series of brand new tools and paradigms that have to develop in this space, and that's where we're in the evolution of right now.
Yeah. And I think, and again, to sort of summarize and simplify that. So it's like we've spent 20, maybe it's 30 years developing these systems and processes and approach and kind of sharing that information out through the developers of the world. And everybody sort of speaks relatively the same language, and they all kind of know what the tool chain is constructed of, which parts exist in that tool chain. And now they say, great, we're going to do some model development. Well, let's just use the same process and kind of use the same language and try to build some models with it. And it doesn't really work. And so everybody's in this process right now of going, okay, well, what is the correct tool chain? What are the components that we need? What are the processes and the process steps we need to take? And how do those sort of loop back on each other? And what does this look like? Because this is a unique and different process and system. It only is like the other thing in that it is a system that has some inputs and some outputs, but everything in the inside is different. So we sort of like need to figure out those components. And that seems like where we're at right now.